Well, hello everyone. Welcome back to Adrian's Digital Basement 2 casual video today, where I'm going to be taking a look at some ISA cards that I've randomly found. Now, there are 3 cards here. The focus of the video is actually going to be on this one, unless this one's broken. And the reason why is because this one is made by VTEC, aka LASER. LASER, yeah. The reason why I want to take a look at this one is this card, which is obviously a CGA/MDA card. Well, it kind of reminds me of this card, which I've made a video on in the past. I love this card. Now it says Santis.1. This is made by VTEC. It's VTEC branded from 1989. What really makes this card special is it has 64K of RAM on it. And as you can see, a couple custom VTEC chips and whatever that thing is. And it says monochrome graphics color adapter by Video Technology Computers Limited. Yes, same VTEC that makes those children's toys to this day. This was the company that made the LASER 128 plus a bunch of LASER PCs, and I'm pretty sure this came out of one of those. Now, what's cool about this card, and I'll just talk about this very briefly if I can get the camera to focus. There we go. So we have a CGA MDA switch. We have 2 RCA outputs. One is for monochrome CGA, one is for color. This one has artifact color enabled. This one has nice shades of gray. But the really cool thing about this is out of the box, it just does CGA and MDA. But there were some unpopulated jumpers, which you could see configured on the board now. So JP6, JP3 not installed, plus these 3 jumpers. I can't remember which ones were there and which weren't there when I first got this card, but I populated all of them and then I kind of went through all the different settings to figure out what this thing could do. And in this exact configuration, this card becomes so much more capable or functional than it normally is. So CGA, MDA compatibility out of the box is, you know, what it is. But with the jumper set this way, this card is now Plantronics compatible as well. So we have 320 by 200 resolution at 16 colors, and I think 640 by 200 at more than 1 color. So Plantronics mode, that's pretty cool. That's enabled by setting the jumpers. And then the other thing this card does, which is kind of fun out of the box, is when you have it set to MDA mode or monochrome, it is Hercules compatible, which is very typical and common, but it also supports MDA color. So I didn't realize that until I had the RGB to HDMI connected to it one day, and I ran a program that wrote directly to the video buffer and the color attributes, and sure enough, there we had MDA resolution and font resolution, a high resolution font that is, 50 hertz, but full color. So of course, MS-DOS doesn't really support that. You know, when you run a program in MDA mode, it's going to be in monochrome. But if you write to those color registers directly, yes, this thing supports MDA color. I just think that's a really cool feature. And it always was that apparently the MDA card from IBM, the one that came out with the 5150, was always supposed to have color support, or at least it originally had color support, and it got removed at some point. There have been articles about how there is the vestiges of color support on the MDA cards there. So back to the original VTEC card, the one with the 2 chips here and, you know, all the capabilities. I love this card, but, you know, unfortunately people have asked me, like, where do you find these? What do you search for? Unfortunately, like, I don't really know. I mean, there's an FCC ID on here, which you can try searching for. There it is, BNX 84H80-2323. And then there is this Santis 1 marking that's on here, plus a couple other things. And then we have the 2 VTEC chips. So 27-73901 and 738-00. From my understanding, this card was always bundled inside VTEC computers. So it wasn't like something that you could just buy separately. So if you see one of these floating around, it would be it would have been taken out of a VTEC PC clone. So if we take a look at these other cards, this is the potentially newer version of that VTEC card we were looking at. So 27-2020-00. So this has 27 as a prefix, as does this, but we can tell that I guess these are older revisions of the chip. And I'm really curious if maybe they just took the functionality of both of these chips and squished that into this one chip, and this has the same capabilities of this card. Now, one thing that's really interesting is this does have these extra chips. I'm assuming if I peel this sticker up, it'll say VTCL under there. So this is like some additional support logic chip. I'm pretty sure this is a ROM chip that contains the character set for CGA and MDA, because that is the one ROM that's installed on IBM's CGA cards. When you use a CGA or MDA card on an IBM PC, the BIOS that's in the motherboard actually initializes the video card. Unlike EGA and VGA, there is no BIOS on a CGA and MDA card. It is completely initialized by what's on your motherboard. And that's why I believe that one of these is going to be a ROM chip, which is probably this this microchip one, and then this is just a VTEC like custom IC that just supports the actual chipset that's on the board. All right, so back to this board. Now, we can definitely tell that this looks like an EEPROM. So this one might actually have a BIOS. And then our FCC ID, if I try to zoom in a little bit more, very different, IFS 80-2323-1. Based on the proximity of the EEPROM to the ISA connector, I wonder if this thing, like I said, does have a BIOS. Now, this bodge that's on here, which I gotta say, good work, guys. They ran through a via under the legs of the chip and over to that one leg on the surface mount IC. Where does that go on the backside? Oh, it goes there all the way up to the top of the board. And they cut a trace. I'll be curious if you recognize this card and you happen to have one in your inventory, take a look at it and let me know if you have this bodge on here with that cut trace and if that does anything. This chip has 64K of RAM as well, just like the other one. We have some unpopulated components. So we have a 16 megahertz crystal, which is the same as the other one. And there's our header for the light pen. We have a jumper down here, JP4. And just due to the proximity of all of this, it makes me think that maybe that is for disabling the ROM. And we notice that, yep, these traces kind of make their way down to the ISA connector, which again, makes me kind of think that that is maybe a ROM BIOS, which is really weird for a CGA MDA card that generally does not need such a thing. Things I'm noticing on this board, there's a little bit of corrosion on it. I don't know the history of this board whatsoever. I don't even know if it works. Hopefully it does, or this video is going to be kind of lame. I'm just looking around to see if there's any unpopulated jumpers like there were on the other one, because if that's something we have to configure to enable, say, Plantronics mode on here, I'm also looking to see if we have any pins on the main chip here that are unpopulated, that don't go to anything. Now, see, these ones here don't look like they go to anything, but the problem is, of course, it could be going to stuff under the board. Under the chip here, there's a whole bunch of vias, where those vias could be connected to any of those traces there that aren't connected to anything. So it's really hard to know, and not without removing the chip from the board, and I'm not sure I'm quite ready to do that. And the reason why I'm thinking about pins that don't go to anything is because when you have jumpers, they typically feed into these chips, and you'll have, say, one position where it grounds the signal that goes into the chip, and the other one maybe pulls up to 5 volts or connects it to something else on the board. And you can kind of see that's what's happening here. So in one position, when they're this way, it's connected to this large flood fill, and in this one, it's the lower flood fill. So one of these is 5 volts, one is ground. And then there are these resistors, and I had to add a bodge wire. I don't know, that trace was missing. And these resistors then go up into this chip. You can see the traces there. Well, one of them goes to this chip. This R7 looks like it goes to that chip, so on and so forth. So that's what I was sort of looking for with this. But I guess the first thing I need to do is we need to test this thing, see if it even works. And maybe it already has all the same functionality of the other card anyways, and then that'll be really cool. Incidentally, Turbo SL, that would be the name of one of the laser PCs, so you can look online or look at history, you'll see lots of those. The next card is most likely what is just a monochrome card, MDA Hercules. These chips, TD3088A, I'm sure if I Google that, it probably is just a MDA card. It has a footprint for both 4464s, meaning, 2 chips for 64K, or these 4164s. So you have 8 chips for 64K. Same 16 megahertz oscillator. It's almost certainly the character generator. Interesting is it has a larger footprint. That almost makes me think that this chip is possibly capable of CGA and MDA. We do have 2 unpopulated jumpers there, extra transistors, some extra resistors. So it's hard to know. Not a whole lot labeled on this thing. I quick Google for the part number on that chip, takes me to RetroWeb, and there it is. So this is just a monochrome graphics chip. CRT-C 6845 function built in, printer port function. It's sort of how they got with these, where everything just ended up being integrated into a single IC just for incredibly cheap cards. In fact, if they used these chips, they could even lop off this entire section of the board. And there were monochrome cards, people might remember, where the PCB was literally a triangle and everything was just squished into the smallest footprint possible to give you a monochrome and a printer port. Let's see, yeah, there's our chip. So there isn't even CGA support. Doesn't appear we have any documentation available for the chip. So if we did have the data sheet, we could at least try to look up what this stuff does. But yeah, I wouldn't be surprised if maybe these jumpers are maybe for a larger ROM chip that gives you multiple character sets. Is that a cut trace there? No, I don't think so. It's just a little scratched up. Not much on the back side here. It could easily be, though, because this has printer support built in, that this is simply to disable the printer port or change the base IO or IRQ, stuff like that, kind of boring stuff that is all due to monochrome cards. And then the final card I have on the bench is this one, which is just a color graphics printer video board. So complete clone of the CGA card made in Taiwan. It has the UMC parts on it. It's got a PAL. It has an RCA jack, hilariously, on the inside. But the reason why they did that is because this adds a parallel printer port, and there's no room on here to add the RCA jack on the outside. It does have the light pen header, which is right here. There it is. I'm sure that's standard issue. There's our character generator. There's another PAL. Here is our RAM, which, because this is a 41416, this is 16 kilobytes, which is a typical amount of RAM for CGA cards. So that tells us right there that this is just a normal CGA card, and it does not have the capability of doing Plantronics or anything like that. It's in good shape, although annoyingly, it's got this lower section here, which prevents you from plugging it into 16-bit ISA slots, but original IBM cards had that as well. Not much to say on this one, other than I'm sure this is literally just a direct clone of IBM's card, and with all of its snow and flashing and other issues that the normal CGA cards have. Okay, so let me move those cards out of the way, and let's focus on this card. So I have my test bench here. Let's get this connected up. First, I guess I'll test out this card, just make sure everything is working properly. Turn this on, and sorry about the flashing. There will be some flashing in this video because of the initialization process. This card is initializing, so that's cool. Got the keyboard here, and I'm pretty sure everything is going to be working properly. And of course, this is my normal boot image, so I have stuff like Planet X3, which has Plantronics mode. Thank you, David Murray, for implementing this. There it is, 16 color mode. I know this looks like it's in 160 resolution. It's because the assets that David used on this are the lower resolution ones. This is not as high resolution as is possible, but actually Attack of the Pesky Robots on the PC, this does have higher resolution assets. There it is, 320 by 200 at 16 colors. And this is a 36SX running at, I think we're at 40 megahertz right now, so it's pretty speedy. That's why we're having no issues updating the screen. It's fast and playable and looks a whole lot better than normal CGA. Okay, so let's plug in the other Santa's One card. Let's hope that this card actually works, first of all, and then we'll see if it has the Plantronics and the color MDA stuff. Oh, interesting patterns. So that's the same. So what's happening there? Oh, B6 auto switch BIOS? Okay. So this is a BIOS chip here. Or one of these is, but it's almost certainly this EEPROM. Why isn't it booting? It could easily be that, well, I don't know where this BIOS lives. Is it somehow conflicting with the XT IDE? Possible. Well, let's try switching this jumper on here, JP4. Let's see if that changes anything. Put this in the other position. Maybe that is there to disable the BIOS. Ah, yes, I think that is exactly what happened. Because notice how this is in 40 columns mode, and we go into here now. Yep. So I think before, I didn't go into the BIOS with the jumper set that way, but I bet you would have set EGA, VGA, because this motherboard can auto-detect if there's a BIOS or not, and it uses it. Older PC XTs, you have to set jumpers and stuff appropriately. Let's switch this over to 80 columns mode, and I'll save this. Now, I definitely need to dump that BIOS so we can kind of analyze it and see what it does. But let's see if the computer boots now without the BIOS installed. I mean, this could easily have been a problem conflicting. Yes, that was it. All right, so right off the bat, what's nice is no flicker, no flashing, no snow. It's just like the other card in that regard. Let's go to games and right away check to see if we have Plantronics support. Here we go. Oh, we do not. This is what happens. There are more bit planes in Plantronics mode. And when you don't have Plantronics enabled, then you get some of the bit planes, which is why it looks like this, like CGA, but we're missing all the other extra colors. And yeah, well, that's really unusual. Why would one card have Plantronics mode hidden behind jumpers, and then this one not? Well, that makes this card way more boring. I was hoping that it would be interesting because of the extra features like this card, but nope. I'll switch this over to MDA, and let's see if we have MDA color support. Okay, I've switched the RGB HDMI to MDA mode. Yeah, that's weird. So switching that switch, which on the other card just works. I think it does at least. Maybe I should test. Maybe I have to set a jumper on this board. There is a color monochrome jumper right here. Isn't that weird? Static. Let's switch over to the other card. Just make sure this motherboard is working in MDA mode. Like that. Pop this in. And see what happens here. Okay, yeah. Oh, no, see, it works. The profile's not quite right for the RGB HDMI. I thought there was an MDA color jumper, but I guess you don't have to set that on this motherboard. Yeah, there we go. It auto-detected monochrome. Oh, but it does say display switch not proper. All right, so I'm going to swap the jumper over to the other position. I think it's that jumper for color monochrome. Oh no, that's the CMOS clear jumper. Whoops, made a mistake there. I didn't see, but the jumper for color mono says right here JP4. Where is that on the board? Yeah, there it is. It's over by the memory. I have to say I've never switched this. I think I always just leave it. Even when it says like display switch improper, I'm like, whatever. It just seems to work generally. Just leave that off for now. All right, let's see if that made a difference. I'm gonna have to go edit the options in the CMOS setup. The fact that it said battery low before, that was because when you clear the CMOS, I think it basically just disconnects the battery from the clock chip. And that causes the system to not post necessarily. Just put a random date, I don't even care. I think I have to do shadow RAM set to main for the system to work super reliably. I can't remember all the specifics. It's weird that the BIOS itself would have things that are not quite right, but I think it might be because I used the BIOS from a different board on here. Not sure. Either way, there we go. It's booting. Okay, let's switch back to the other card. I want to know, is it just because the jumper was set wrong that this thing is not working, or does it really need this BIOS for it to work properly? No, it still doesn't work. So this card doesn't work correctly in MDA mode. Interesting. Should we try turning the ROM back on? I don't think that matters. I'm wondering if like the auto switch stuff that, you know, the ROM when we booted up said auto switch. I wonder if it was like a keyboard shortcut. No, this still doesn't work. Yeah. Unhappy. Odd is I think the ROM BIOS is actually working now and it's trying to initialize the card in MDA mode. It doesn't work either. So there's definitely a fault on this board of some kind. Okay, I spent a little bit of time just checking over this card, making sure that everything was connected, and everything is connected. I looked specifically at the area here with the corrosion, so I had some flux and I was cleaning it up, but everything tones out correct here. Like there's no bad traces whatsoever, even though there's a little bit of corrosion there. I even checked to make sure that this DRAM connection was making its way through to this IC on the chip, and it was. In addition, I checked to make sure all these surface mount legs were soldered down, and they are. And then of course I removed the labels. So this is our ROM BIOS. And then I removed the labels, obviously. So this one actually, interestingly enough, it matches the one on this card. So that's obviously our character generator. 27-672-01-03, same exact part number. And then we have our ROM BIOS here in this 8K EEPROM. Now what's interesting is that makes me think that this is actually a ROM BIOS as well, but I have never seen this card, no matter how the jumpers are configured, present a ROM BIOS. And if it is the same kind of code that's on here that maybe allows you to switch with software between MDA and CGA, which is kind of a nice feature. You don't have to reach around the back of the machine and switch that over. But unfortunately, I really could not find any obvious faults on this card, which is bad because I don't really know how to try to fix this. If there is a fault, it maybe is inside of this main IC. When it comes to jumpers and things like that, it really is just this one resistor. So this is connected to the switch, that middle pin, and it's either 5 volts or ground, and then that makes its way to the main chip through a via. I'm noticing, I just realized there's a space for a jumper, and this is on this board. So why don't I clear that out and get that installed? And the middle pin of that goes to that via there. The via makes its way to a trace somewhere down here, so it doesn't seem like it's related to this stuff up here. Although, where do these other two connections go to? Each side of that jumper. So the only thing I have to do is figure out how this stuff is connected. It looks like this left side pin goes to a resistor that's not installed. And then where does that go? Oh, okay, you know what? It goes to this chip that's not populated, so that resistor must have something to do with this chip. And I wonder if that's something related to this jumper, which I don't remember if that jumper does anything on this board or not, because it's sort of in the area also where there's a missing chip and some extra components. There's a diode and stuff like that. I almost feel like this jumper allows you to maybe select a separate crystal, maybe to run this at a different frequency, 50 hertz, for instance, perhaps in different regions. And that chip is necessary. Maybe you set that jumper to like pick between each of the crystals. I realized earlier I was saying that I thought it was possible that the BIOS was conflicting on this with the card, but that's obviously not the case, because I'm pretty sure this card, when the BIOS is turned on, shows up as like a VGA, EGA card to the BIOS at least. And the BIOS that's on this card is what configures the chipset and everything that's on here. All right, running Jim Leonard's CGA compatibility, sweet. We can take a look at the speeds, see how this compares. 809K for, what was that, read, block memory read, block memory write, also 809. And it looks like for interleave, we're getting 775 and 699. And if we look at 6845 compatibility, I'm sure this stuff is all going to be pretty close to real. Oh, it's a little bit faster the refresh rate than CGA. Raster bars work, although there's a little bit of glitching on the right side, which I don't think happens on a real IBM card. The row reprogramming, this works fine. Positioning worked fine, and start address is probably going to work fine as well. Yep. All right, so it's pretty compatible. It's just not exactly the right refresh rate. Therefore, if you tried to use this with some of the demos that are written to like really take advantage of CGA cards' exact timing, it's not going to be a suitable card for that. So the read block speed was 899 kilobytes per second, which I think should translate to very similar results in here. FPU type is garbage. That's weird. It's got an ITT one. Anyways, 828 characters per millisecond. Yeah, it usually coincides pretty closely. Now I'm thinking that possibly we can look at this ROM BIOS if I just add the jumper on while the system is booted. Let's see if that works and the computer doesn't hang. All right, computer is still working. All right, so this is Jim Leonard's ROM dumper utility. Dumps all the ROMs, but we will be able to get the ROM from this card. So pretty sure the ROM that is at C000 hex, 8 kilobytes, that is this ROM. Although what is at C200? Let's take this off and run this again. Take that jumper off. Yeah, that's weird how it's presenting as both C0000 and C200. It's only an 8K EEPROM, so it's not possible that it could do both. Let's try editing the ROM. Soft lock. H key. Wait, what? I mean, this is definitely what's on this card. So this is the C000 ROM. How odd. Looks like there's a menu here or something. B6 auto switch BIOS V1.1. And it looks like it can display some kind of a pop-up screen or something. So there must be a key sequence. Oh, there's not a lot on this chip either. Let's look at the other file. I think it's called this. Oh, same thing. So the address decoding. So this thing actually supports 16K EEPROMs for some reason. And this ROM is just in here twice. Pretty sure this is going to be absolutely identical. Yes, it is. What is entirely possible about this BIOS is that it works fine on XT class machines or even 286s, but not on 386s. This thing is probably way newer than it was ever designed to be used with. Oh, shoot. I wanted to enable the BIOS, and I think I disabled it. Let's reset the computer one more time. I wanted to show that it probably shows up in the BIOS as VGA card. Yeah, B-switch, auto switch BIOS, B-switch, B6. Yeah, VGA, PGA, EGA. It's entirely possible this BIOS conflicts with the XT IDE that's on this card, or it doesn't like 386, but I just don't even know what functionality it would support anyways, not to mention the MDA support is broken on this card. But this does give me a little bit of an idea. Let's put in my original card, and let's see if I can fiddle with these jumpers while the system is running to see if I can see the BIOS that might be on this card. I think is maybe in this chip here. One thing I'm just going to quickly check on the card that I like, the one with Plantronics. Let's just check out the speeds on this. Oh, it's half the speed? So this was $899 on the other one. Wow, that's really curious. And this was $809, it's $478 here. And interleave read was $775, and now it's $437. And the write speed is $451, and it was $699. Okay, that's pretty amazing, actually. I poo-pooed the other card, but it does have faster video update rate. This is probably generating wait states. Maybe that's a jumper configuration, to be honest, on here. You know, when I went to figure out all the jumpers and what they do on this, I never actually did benchmarks. I just sort of, you know, tried to change them and see if there was visual changes. And I don't even know what made me think of Plantronics support, to be honest. But why don't I just do this? Because this is sort of, it's not real time, but I can just like swap this JP6, for instance, over to the other position. Nope, that didn't change anything. And this was whatever the first one was, JP5. That didn't seem to change anything. Now the middle jumper, whatever that one is. Nope, same slowness. There's only one more left. The one that's left is the closest one to the ROM chip, or the potential ROM chip. None of them caused the card to freeze, and none of them had any effect on the speed. Now that's not to say that maybe I have to reboot the system. I mean, it would take a while to kind of go through all this and try. But I'm assuming they just optimized the wait states with the new version of the card to go faster. Okay, so let's try ROM dumper. Oh, in fact, let me start up DOS key so I don't have to type this over and over again. Okay, so I'm going to switch these jumpers one by one, and we'll see if any of them have any effect on bringing the BIOS back. No, none of those jumpers had any effect on like bringing the ROM back. I just noticed there's another jumper here, JP3. Let's put that one on. I don't think this would do it. Nope. Let's see if this has a RAM speed effect. No, it does not. I don't know what JP3 even does. Doesn't seem to do anything. Switching back to this card, it's really obvious that it is a lot faster. Definitely text update rates. Yeah, it's noticeable. So this is actually pretty nice for, you know, a CGA card if you want high performance. It just, the lack of Plantronics kind of sucks. So it just means I'm still going to use this card. And then of course, I do like the whole switching thing for monochrome, but the fact that that doesn't work, that does not. Oh, look at that. It stays in CGA mode. You have to actually power cycle it. I flipped the switch. It's the fact that it's not working. There's not too much I can do for troubleshooting wise. Like when a card is all highly integrated like this, where everything is just sort of in the main chip, there's not a whole lot to troubleshoot. And the fact that the card is functional, 100% functional in CGA mode, sort of tells me the RAM is fine. I mean, I don't know if all the RAM is fine, but the thing is normal MDA mode doesn't use all this RAM. The 64K is for Hercules and Plantronics, but we don't seem to have Plantronics on here, so it's really for Hercules. Just text mode barely uses any of this RAM, and it would use the same RAM that it would be using for CGA anyways, and it's fine. And we're getting it to do the beep thing, which is telling me that the BIOS on the computer is trying to initialize the chip, and it's not able to. Like, it's not able to see the video RAM properly, or something along those lines. You know what I could do, actually? I could run both of these cards simultaneously. Let's give that a quick try. Maybe there's an issue with the video memory. So with them both in there, this one's set to CGA, the one on the bottom is set to MDA. The computer should still work without issue. Okay, let's see what it complains about, if anything, the BIOS. Okay, nothing. Okay, so that's the memory. I read it twice. The bytes, they all look the same. Okay, so I think I just filled 100 bytes with AA at B000. So we look at that. That definitely did not work. So it's like the RAM's not working in this MDA mode. Now CGA RAM starts at B800, and we can do the same thing. If we fill this with AA, there we go, we wrote some of that there. So that's working fine. But the weird thing is, did you see how slow it was? If we try to write to that memory space again, 100 AA, should just be instant. But look how there's a bit of a delay. So something's messed up there. Definitely not really. Look how slow it even read out. Now look how there are some AAs there. Let's try that one more time. We're going to write DD to it instead. it shouldn't be that slow. That's probably why it initializes the card so slowly. You know, when it tries to boot up, it just sits there forever. Yeah, look, it wrote some DDs in there, but I really don't believe there's actually a problem with the DRAM on that card, just like I said, because CGA works perfectly, and it's super unlikely that it'd be using a different part of memory. You know, when it's in MDA mode, it's going to start from the beginning of RAM, and when it's in CGA mode, it's going to start from the beginning of RAM, and both of those are working fine. You know what, we can do the same test. If I swap these cards around, I'm going to switch to the other one. I'm going to flip the switches the opposite way. So the top card is now going to be MDA. The bottom one is going to be CGA. All right, here's that same test. So that is the MDA range, but in this top card. Notice that didn't stutter or anything like that. And we do the same thing for the CGA card. There's a broken card. And we fill 100 bytes of B800 with AA. There we go. We get the same thing at the top, just like we did before. But, you know, I'm using the bad card right now. But if we try filling the MDA card, same thing, no pause. And if we look at the card there, it filled it with all A's. So yeah, in MDA mode, the reason why it's broken is because most of the RAM is not working for some reason in MDA mode, but in CGA mode, it's fine. All right, well, I'm about to end this video, but let's just do a little bonus content and we'll just quickly test out these other two cards. Start with the CGA card here, this giant card. Oh, I can't even plug it in because these have the little 16-bit slot extensions on them. So out comes the riser, but I do have one slot on the motherboard we can just plug this into. Incidentally, people probably noticed this before. Look at the serial number, 370. I don't know if that is a serial number or that's a model number maybe or something, but that's kind of funny if that is a serial number. It's so low. Okay, powering this on. The fact that it's black right now tells us that this will have flashing. And the reason why the other card shows that random garbage is because when the chipset initializes, you know, the BIOS isn't ready to blank it out yet or clear the screen, and it just shows this random junk. And then typically what happens with the original cards is they power up in a blanked state where they have the video turned off. And the reason why you have this flashing is because it wants to try to avoid the static that happens during the RAM updates when you're scrolling. So the BIOS blanks the video output. So there's a register on the card to do that. Well, cards that don't flash when you type DIR, like the other ones, they don't honor that register. When the register right to turn off the video is sent, it doesn't actually do it. But this card, it does it. So one thing about this card, when you look at it in the real CGA card, it doesn't have a crystal on it because it's taking its crystal stuff from the motherboard. And that makes the fact that the clock speed is exactly correct. So true CGA 59.9228, and notice this is 52.9228. And that's because the motherboard's supplying the frequency generation to the card. And it's based on like the, you know, NTSC dot clock and all this, that, and the other thing. But the VTEC cards have their own 16 megahertz and their own dividers, and that's why it's not 100% accurate. So I think if we look at the horizontal retrace now, we won't have the little glitches on the sides. Oh no, you still do a little bit. We will have snow on this card though. Yeah, there it is. Jim Leonard's snow demo is very cool. If we tried this on the VTEC card or the laser card, it wouldn't do it at all. I am curious, what is the VGA or video speed on a real CGA card on this computer? Oh, 641. So this card is faster than my beloved card. That's interesting. Very interesting, actually. So it's kind of in between. Oh, yep, that's still a bit slower than the real thing. Interleaved, 561. It was 775 on the bad card. And there we go, 690. It was 699 on the bad card for write, and it was a lot slower on my card that I really like. Anyways, this card does seem to work. I didn't test the parallel port, but I don't really care about that. I'm noticing a jumper that allows you to select the parallel port address, but there's nothing to disable the parallel port, so that's kind of lame unless I'm missing another jumper. It's also interesting, it says video, but then it says video over here. Is it like another possibility of an RCA jack? It's possible there was a version of this that didn't have the 25-pin connector, and there was some type of like video jack over here somehow, maybe. And lastly, we have our MDA card that we looked and saw that it was definitely only monochrome, so kind of boring. Hercules and monochrome, not much to say about this. So there we go, looks good, nice and sharp, nothing to complain about, except for the display switch not proper, but you hit F1 and it boots anyways. And we can run robots in Hercules mode. This should work. Yep, there we go. That's just how it looks. The way David wrote the game, it kind of adds those extra scan lines because it doesn't have assets directly created for like the 350 lines or whatever, how many lines you have in Hercules graphics mode. It's like 350 something, I think. I have this vid test program and I run MS-Herc first. And then I think this allows us to do, please be sure you've loaded QB-Herc. I think it's the same thing as MS-Herc. And I think this stuff works. Yes, there it is. So we can get high resolution graphics out of this thing. And that's all there really is to say about an MDA Hercules card. It can do high res text, it's 50 Hertz, and you get high res graphics modes. And I think there's like redefinable characters for Hercules mode. I don't think anything really uses that. And we also have, I think, multiple pages of text or graphics mode as well with the Hercules mode, over and above, of course, MDA, which doesn't have any graphics modes whatsoever. Okay, well, that's it for this video. Unfortunately, this card I thought was going to be cool with the Plantronics mode. And to be honest, if it had Plantronics but MDA was broken, I would still be happy with that because this is a fast performing card. Better than my beloved here, which runs so slow, actually, now that I realize that. But this does not have Plantronics mode, so it's just CGA. So that's something, I guess. I'll upload the BIOS to archive.org. So if anyone wants to try to disassemble that to see what it is, you can do that. It's a bummer that this thing is broken, but I don't really have any idea of how to test any further. I am positive it can't be a RAM problem. There's no way the RAM is that broken when it works perfectly in CGA mode. So there's got to be a problem with the main chip on here that is causing that particular issue. And that's really it. So boring card, unsatisfactory because I didn't fix it, and some other cards that do work and they're super boring as well. So there we go. If you enjoyed this video, for some reason, thumbs up. But if you didn't because it sucked, you know what to do. And yeah, there we go. If you like this kind of me just waffling on and fiddling around with some useless cards, then let me know in the comment section so I can make more of these because I have a ton of random cards like this. And this is just stuff I normally do off camera, but to be honest, I was like, let me just turn on the cameras while I make this video. And there we go. Thanks to my supporters. Thanks to my subscribers. You know, the usual YouTube junk. And that's going to be it. So stay healthy, stay safe, and I'll see you next time. Bye-bye.